Okay, so your basic quadratic function is y equals x squared, just your squaring function. Okay? Now, stretch. Okay? If we move every point 8 times as far from the x-axis, the graph is going to look something like this. If you did the homework correctly, just understand this, okay? If not, you need to go back, look at videos, whatever. Make sure that you do homework, add it in late if you need to. Point penalty, but you still get some credit, okay? So, we call this the vertical stretch. We vertically stretch the graph by factor A. Okay? Function now ax squared. So this function is okay. Then we move every point 3 units lower. Okay, well, that's easy. You understand if you do that, and you do it with the arrows like I asked you to do for homework. Then that's this graph that we're going to move 3 units lower. So it's going to open just like this graph. It's going to be a copy of this graph, move 3 units lower. Okay? And what function do you want to call that? That's y equals what? Actually, I used the number there. I used 3. And I'm going to change my language here because, and forgive me for using bad language, but, okay, so we're going to move every point k units in the vertical direction. Now what can you tell me about k? If the graph moves downward, k is going to be negative, right? And we don't write negative k, we just write k. K can be positive or negative, depending on whether k is positive or negative. The graph will either move up or down that far, okay? So now we have the graph. We started with the y equals ax squared. And now it's ax squared plus k. Okay, so if k was negative 3, that might be what the graph looks like if we move this graph negative 3 units in the vertical direction. Ax squared plus negative 3, of course we'd write that as ax squared minus 3. So there's the graph. And I'll call that a vertical shift of k units. okay? And then later I might abbreviate that vertical shift K. Right now, I want to be specific about what we mean. Okay, then, shift the graph H units in the X direction. Okay, so that means we just move the thing over, and I'll make a positive move because I don't have much room to the left. Okay? Also, I want to emphasize something about this. Okay? So then we the arrow indicates to do it in this order, right? We move every point H units and I said to the right because that's where I'm going to move it. What I want to say is H units in the X direction. And that's a horizontal shift. The function is now A times X minus H squared plus K. We move to the right, but it's X minus H. The reason is to get the same Y value for X minus H, X has to be H units bigger. Okay? And that's an important statement. Hopefully you understood it. I'll kind of repeat it. It's counterintuitive. You would think it'd be X plus H because you're moving in the H direction, but no. It's got to be X minus H because to get the same Y value, X would have to be H units bigger. Okay? You might not totally grasp it. That's not a simple concept. If you grasp it, that's very good. It's not a horrendously complicated idea. It's not obvious. Okay, so that's what we've got. All right? Okay, so let's look at what A times X minus H squared plus K gives us if we expand the square. So first of all, I'm going to digress to another exercise over here to emphasize something important. I'll apply that out and write it clearly, something I can read. Know your names so you don't have to necessarily put your name on the paper like as before. Okay, I see people doing all sorts of things. Most of them look like they have a high likelihood of working. Okay? But the way I'm going to do this is using laws, not pictures, diagrams, arrows, and arcs and stuff. This equals x times 3x minus, times x squared plus 3x minus 4 minus 5 times x squared plus 3x minus 4. Distributive law of multiplication over addition. Okay? And this is what I want you to use. Okay? Some of you make a table. I'm aware that that's probably what they teach you to do. If you got a table like this, and you put your x and your negative 5 and your x squared and your 3x and your negative 4 here. That works, but it doesn't really explain that you're using the distributive law. Okay? Can you explain why this is equivalent to the distributive law? Maybe you can. But the distributive law says one thing only. It says that this works. We'll write out the distributive law more formally, but you understand this. Okay? This gives you the same answer, but we're not just looking for the answer. We're looking for an application of a law. Okay? It's the way numbers behave. This isn't the way numbers behave. This is. And unless you prove that this is equivalent to this, you should be using this in this course. Okay? I don't totally disagree with teaching people to do this if you're teaching people who will never grasp the distributive law. It's a quick and dirty way to get something without using the laws. So I don't totally agree with you. We're not using this here, we're using this. Got it? Okay? So this is obviously then x cubed plus 3x squared minus 4x minus 5x squared minus 15x plus 20. Right? And then we simplify that. We have a 3x squared and a negative 5x squared. That gives us, negative 2x squared and negative 19x plus 20. Okay? So I'm going to give you some expressions that use the distributive law, and I want to see it written out in explicit steps. This way, not this way. And I always did this. Now, if I've got 4 terms here and 5 terms over there, that's going to get a little bit noxious. Okay? It works if you don't have many terms. That's what I always did. Okay? But I knew the distributive law. I just wrote it that way because it was quicker. Okay? So, this is not what I want to see. This is not what I want to see. This is what I want to see. But if you do this and then want to check it by doing this or this, I'm fine with that. Okay? It's not that I never want to see it, but I never want to see it unless I see this. Okay? Okay, there's a distributive. Okay, so can you expand this? You know what expand means? It means multiply it out. Just like we did this. Here, we expanded this and we got this, right? If you haven't repeatedly been asked to expand things, then unfortunately, you haven't learned an important terminology or something. And there are probably other things you didn't learn in your algebra course. But you expand this. It means you multiply out the square, not using a formula, not using a habit, but using the distributive law. So how are you going to do that? How are you going to apply the distributive law to expand this?
You distribute the capital A first.
I'm sorry, there's always somebody talking in the hall.
Do you distribute the capital A first or the exponent?
Well, what's the order of operations? A great question. So the answer is through the order of operations, right? What's the first thing you do with the order of operations? Parentheses,
Exponent.
exponent. So you apply the exponent. There's your answer. Okay? Good. Okay? Well, okay. So this should equal A, and what does x minus h quantity squared mean? What's the square of a quantity mean?
There's two of them.
You multiply it by itself. So this is A times x minus h times x minus h plus k. So now you have to use the distributive law to multiply x minus h by x minus h, right? So that's A, and I'm going to have to introduce another parenthesis here. That's x minus h times x minus h is x times x minus h minus h times x minus h plus k. Well, finish it for me.